Sometimes, when thinking about the moment humanity first discovered gravity, it starts feeling like we never fully understood what we had actually discovered. Newton gave us mathematics. He said two objects attract one another according to their masses. And honestly, the math worked. Planets moved, apples fell. Engineering worked. Everything seemed perfectly logical. But then humanity did what it always does. It started asking questions. Why? Why do two objects pull on each other? Why is there an invisible connection between them? Why does this effect seem to ignore distance? And why is it so weak? A simple magnet can overpower the gravity of the entire Earth. Even that alone feels strange. And this is where Einstein enters the story. Because Einstein introduced a deeply unsettling idea. Maybe there was never really a force pulling things together. Maybe what we call gravity is geometry itself. And eventually, everything circles back to the dead sheet. Not because it's some sophisticated scientific device. Not because it's a complex machine built in a laboratory. But because sometimes people try to explain the most complicated ideas in the universe with the ordinary objects they use in everyday life. A simple sheet. Because the sheet shows something important. Space geometry. A bowling ball placed on top of it. Small marbles orbiting around it. Maybe even a baseball. And people say, look, mass bends space-time and everything else moves inside that geometry. Of course, the metaphor itself is incomplete because the slope formed on the sheet is still being created by gravity itself. So, in a strange way, we are using gravity to explain gravity. But the point is not to perfectly recreate physics. The point is to understand how geometry can begin feeling like attraction. An imperfect metaphor, but a powerful one. And while thinking about all of this, one song keeps returning to my mind. Nights in White Satin. For some reason, the universe sometimes starts feeling like two lovers endlessly falling toward one another. Unable to escape, changing each other simply by existing. And what is being said here is not a scientist delivering final answers. It is closer to the thoughts of someone curious, someone trying to understand what they're saying, what they're feeling, what keeps lingering in their mind. Now imagine space completely empty. No stars, no planets, no galaxies, no white dwarfs, no black holes, just emptiness. And somewhere in that endless emptiness, place a heavy manhole cover at one end. At the other end, a flower vase. And yes, I realize that image sounds a little absurd. But honestly, isn't it even stranger that two objects separated by unimaginable distances can still pull on one another at all? The distance between them is almost impossible to imagine. But this is where the sheet starts becoming meaningful again. Because even the smallest curve formed on the stretched surface never completely disappears. It weakens, it becomes almost perfectly flat, but it never entirely vanishes. And if spacetime truly bends geometrically, eventually the flower vase would begin moving toward the heavier manhole cover. And at that moment, space-time itself will begin bending. Of course, the vase is also pulling on the manhole cover. But because the manhole cover carries far more mass, the vase slowly begins falling into its geometry, into its orbit. And maybe this is why gravity feels so strange. Because even when the curve becomes too small to notice, it still continues creating the bending of spacetime we experience as gravity. Then another question appears: the speed of light. And this is where the sheet metaphor starts becoming even stranger. Because maybe mass is not the only thing capable of affecting geometry. Motion, energy. Normally, if you gently place a baseball onto the sheet, it creates only a tiny deformation. But if that same baseball is fired into the sheet at extreme speed, the effect can begin resembling the collapse created by a bowling ball. And this is where things become interesting. Even though gravity itself is still pulling downward, once the sheet is imagined vertically, the baseball almost starts looking like it's deforming geometry along the direction it travels. Maybe this is why imagining the sheet vertically sometimes feels more meaningful. Because the point is no longer simply falling downward. It becomes the relationship between motion and geometry. The baseball is still the same baseball. Its mass has not changed. What changes is the energy carried by motion. And then another question appears. Why does time slow down? Why does the required energy continue increasing? Because near black holes, we already observe something very similar. A falling astronaut begins appearing slower and slower. Time itself starts behaving differently. And maybe what happens near the speed of light behaves like a related interaction with the fabric of space-time itself. Maybe at some point, space-time stops behaving passively. And this is where the image itself begins changing. Instead of a normal hole, the mind starts imagining something closer to a bottomless cylindrical void. Not because a black hole literally cylindrical, but because the bottom can no longer be seen.
Oops.
Imagine two astronauts, and one of them begins falling toward a black hole. That
Gasp.
is the moment
Max.
everything starts becoming strange. If you continue staring toward the black hole, your companion begins looking frozen in place. But they are still falling. The descent simply no longer resembles ordinary motion. Time stretches. The scene stretches. The moment refuses to end. And from above, that astronaut's descent slowly transforms into something endless. Then eventually they disappear. Maybe only a few minutes passed for them. Maybe for the universe, billions of years. Physics may say one thing, but sometimes the bond between two companions feels stronger than gravity itself. And then another thought appears. Maybe space-time is not truly matter. Maybe it is geometry, a fabric. Because if it were literally a physical material, of course it could not stretch forever. But space-time seems to behave differently, almost like the endless rows inside a video game that continue generating as the character moves forward. Because the simulated environment is not only the visible image, there is something deeper beneath it. And maybe this is why the speed of light starts feeling less like a speed and more like a geometric boundary. Energy continues being added, the object continues being pushed. But even while the sheet keeps stretching, The stretching itself almost behaves as if it cannot propagate faster than that final limit, the speed of light. And because of that, the object begins stabilizing around that boundary. Not because motion has stopped, but because geometry itself seems unwilling to allow more. And maybe that boundary is connected to something larger. Not the sudden destruction of the universe, not really completely collapsing, but the idea that existence itself may depend on certain constants, certain balances, certain limits. The universe seems filled with numbers that refuse to change, ratios that remain stable, boundaries that preserve structure. And maybe those natural limits preserve the relationship between everything that exists, and perhaps even things that no longer exist. Then gravitational waves enter the story, and this may be one of the most poetic discoveries modern physics has ever made, because when enormous objects move violently, space-time itself begins rippling. Not waves moving through space, waves of space itself. Technically, every object creates them. A chair, a human footstep, but those distortions are far too small to measure. Black hole collisions are different because the geometric disturbance becomes so extreme. The resulting ripples finally become measurable, almost like the universe itself trembling. And then dark matter appears, another invisible shape inside the sheet. Scientists notice something deeply strange. The stars near the outer edges of galaxies were rotating at nearly the same speed as the stars near the center, but accordingly only to visible matter that should not have been possible. Those stars should have drifted away long ago, but they didn't. Something invisible seemed to be holding galaxies together, and that is how dark matter entered physics. It was not seen at first, it was felt first, an invisible weight, an invisible collapse inside geometry. As if another unseen bowling ball had already been placed onto the sheet. And maybe the strangest part is this. When looking at the large-scale structure of the universe, galaxies, clusters, cosmic webs all seem to require far more than the matter we can actually see. Almost as if the universe possesses an invisible skeleton. And then warp drive enters the story, a concept most people recognize from science fiction films. But the core idea itself is fascinating. Maybe the goal is not truly moving faster. Maybe the goal is changing geometry itself. Imagine the sheet once again. A hair clip attached to the one side, a tie pin attached to the other. Normally, the distance between them is enormous. But once a massive iron sphere is placed at the center of the sheet, the collapse begins pulling those distant points closer together. And this is roughly how warp drive is imagined to function. The sheet itself never truly exceeds the speed of light. Instead, space compresses in front of it and expands behind it. Geometry changes, distance shrinks.
That idiot will never reach me!
And wormholes feel like another version of the same idea. Except this time, space-time is not temporarily gone. It feels more like two distant parts of the sheet are being stitched together. A permanent passage. a doorway connecting impossible distances. But then another question appears. How long can that stitch actually hold? Because the sheet constantly feels as if it wants to pull back apart again, as if space-time itself is continuously trying to return to its original form. And holding a wormhole open starts feeling less like opening a portal and more like desperately holding open a door that constantly wants to slam shut. And through all of this, the same thing keeps returning again and again. Geometry, black holes, dark matter, time dilation, gravitational waves, warp drive, wormholes. Maybe these are not separate mysteries. Maybe they are all different consequences of the same geometry. And maybe that is why the sheet metaphor never completely disappears. Because after a certain point, it stops feeling like a classroom demonstration and starts becoming a way of thinking about existence itself. A universe where movement in one place can still affect another place unimaginably far away. A universe where mass changes time, where motion changes geometry, where invisible structures hold galaxies together. And maybe strangest of all, while humanity quietly sleeps beneath everything, space-time itself may still be the rippling underneath.